Good evening, and welcome to the College of Engineering Distinguished Speaker Series. My name is Eren Armanius. I'm the Chair of Mechanical and Aerospace Engineering. And before we start, would you take a moment to silence your communication devices, biological or otherwise? It's my honor to introduce tonight's speaker, Mr. Chris Singer. He is Director of the Engineering Directorate at the Marshall Spaceflight Center. What the Engineering Directorate do? Well, it better be God. What the Engineering Directorate does is work on design, testing, evaluation, and operation of spacecraft systems, space transportation, propulsion, scientific instrumentation, and payload operations. Also, the Marshall Spaceflight Center is a center for payload operation, and that's the command center for the Space Shuttle payload research for the International Space Station payload research. And that's my connection with Marshall Spaceflight Center. I did some research work for the Space Operation Integration System. Mr. Chris Singer joined the Marshall Spaceflight Center as a rocket engine specialist in 1983. The same year, he earned his bachelor's degree from Christian Brothers University in Memphis, Tennessee. He rose in the rank to his current position as director in 2012. In 1992, he took 1 year where he served at the NASA headquarters, and he was senior manager for the Space Shuttle main engine and external tank. He received numerous awards. I'm going to just name 3. First one is a presidential rank award for meritorious executives, and that's the highest honor that can be bestowed on a career federal employee. He also earned the NASA Outstanding Leadership Medal, and then the Silver Snoopy Medal from the Astronaut Corps. Recently, I was intrigued in a research that they have done, which is in a 3D printed injector for rocket engines. So perhaps you're going to touch on that. That's a feat because this injector had 40, if I remember, 40 separate spray parts that were laser fused from metal powder layers, and they were in collaboration with Valencia in California and directed manufacturing from Austin. Mm-hmm. So with this, please help me welcome Mr. Chris Singer.
Thank you. Thank you. Well, thank you for the kind words and the introduction. Hope I can do it justice. But it really is an honor and a pleasure to be here today, to be invited to speak, and I'm always interested to see what I will say. I spent a little time working on some thoughts, and who knows what will come out. So you guys be prepared. But this fine institute obviously has a long history of excellence, creating all types of folks, from CEOs and presidents of companies, all the way to astronauts, and so it's got a proud tradition of excellence, and so you should be proud to be a part of it. We actually have some connections in addition to, man, that's a blazing sun right there when it came up on my screen. You guys should see this. And it doesn't show up so well there, but one of your professors, and I probably spoil his name, but Yu Ding, has won a research grant looking at solar flares and how the upper atmosphere is affected by solar flares and whatnot. And that is really, really an important factor. We don't appreciate how much, in many ways, we don't appreciate how much our environment is affected every day by the lovely sun that we have blessing us. You also have a professor that's doing research on exoplanet moons. Let me say that again. Non-solar exoplanet moons. Now, I really got to say, when I was in university, we were talking about the possibility of planets outside of solar system, outside of our solar system, the possibility. And now we've actually found them, proved them, and now beyond just looking at exoplanets, we're looking at exoplanet moons. I mean, that's the world has moved a long way, and it's phenomenal. You also have two astronauts, Bob Stewart, and I think you guys are well aware of Kalpana Chawla, who was killed in the Columbia accident, and we'll touch on that a little later. But we have another connection that's just recent. My daughter married a guy from Arlington on Friday. So this is really new, and I'm proud to see a next generation of explorers, as I would describe them. So this should be interesting. But NASA's mission, and Marshall's role specifically within NASA's mission, is around advancing technology, growing our understanding of science, and understanding the world. And Marshall has a critical element in that, which is strongly based in the propulsion and launch vehicle side, from Apollo through Shuttle to today, the next generation exploration vehicle we'll talk about in a minute. Also, the space station, we had a huge part of developing all of the modules for the space station, and continue, as the doctor introduced us, in the payload operations 24/7. You know, station's up there for over 12 years now, and been fully manned. So it's kind of an amazing thing that we don't actually recognize as a community and the public very much. Partly, I think, because it's not dynamic. We're not having a fire or something like that. You know, when it was Apollo, when it was the Soyuz station, we had fires occasionally, and that got a lot of attention in the press. But everyday old operations, you know, astronauts operating a vehicle in that environment, in that harsh environment, doesn't get a lot. And then Marshall also has a role in understanding beyond the universe. The Hubble Space Telescope and the Chandra Space Telescope were both built and designed there. But I kind of want to use this platform to talk beyond the technical. It's so easy to get into a trap. I call it a trap, but put a bunch of eye candy up here and talk about all the cool hardware, all the stuff that you could get off the web or the internet. I want to talk about a little connection to the human factor. So this is going to be a little different talk around how we have very conflicting human emotions that the explorer actually has to deal with, and those who want to operate in this world have to deal with. So hopefully it'll be fun. And it is just innately human. You know, this country, we just celebrated Columbus Day. We were founded on the explorer's heart in general. And this is an old picture. I actually saw these ships about 15 years ago. That's Columbus's 3 ships. They're in front of Columbia on the launch pad. So it's kind of cool. But you think about where we went from Columbus, and then the Mayflower, and in a few hundred years, we're in space. We're flying fully human class in space, and it, you know, the big step of Lewis and Clark to find a Northwest Passage and then find out it wasn't that great, but learning to explore, it's always been in this country's heart. You know, I can remember my grandmother talking about. She used to have a term when I'm going. I move pretty fast sometimes. She said, "Boy, you're just getting like 60." And I said, "What do you mean?" And she said, "Well, you know, that's really fast." She said, "We used to didn't think human body could live above 25 miles an hour." And so just in a couple of generations, look how the world's changed. Breaking the sound barrier. They really, had no idea what that was going to be like, and actually got to work with the test director from that program. It was a lot of fun. And so you move on and you start thinking about how much space has affected our world and how it has changed just in the last 30 years with satellite technology, with understanding the environment here on this Earth. And so it's kind of no small thing if you start looking at all the spin-off technologies that have come out of the space program into everyday life. My favorite, of course, is the electric drill, battery operated. I got a new one the other day. But that started from the Apollo program of needing to have a compact battery operated high torque device. And so that generated a whole new set of technologies that eventually flowed in. We could talk about that a long time, but we'll move on. The space station has been one of NASA's, I guess, premier capabilities that is a international capability. And if you actually look back over the history of the agency, it has been NASA has been a tool of diplomacy in more ways than one. And today, you hear a lot of noise before the Ebola conversation. There was a lot of discussions around the Ukrainian situation in Russia and how that's going to change everything. And yet the space program just continues to truck along because we have got a long-term bond with international partners. And they have no desire, have the same passion that we do about this mission, and they are all about making it work. And it's not new. During the Vietnam era, we had the Apollo-Soyuz program. So as much as things change, I think sometimes they stay the same. And if you got a community that's really committed, they will make the progress. And it's also been a real inspiration for students. This is one configuration that's particularly I like in the station build-up. Give me a T for Texas, give me a T for Tennessee. And I grew up in Tennessee, and so this one I kind of like, and I think about how many people across the world have been inspired by the things that we've been able to accomplish as a country. And as a symbol of our national pride or as a symbol of our national capability, it really doesn't matter. And we have a lot of conversations around, well, does it cost too much? I don't know. How do you put the value on something that no other country has been able to do? I don't know how you put a value on that. I do know that the value, that the price, the cost today for the nation's, your space program, is less than 0.5% of the discretionary budget. So it's down on the low end. We will spend 5 times that as a country on Halloween. So that just to put it in, to scare ourselves. But with that, back to exploration. People get inspired by lots of different things. It can be athletics, it can be new medical technology. But one thing that generally inspires a lot of people is the idea of exploration, the idea of the unknown, the idea around what's behind that hill. It's in our DNA as a race, and it's kind of funny. I've not always been a space program person. As a matter of fact, in the 6th grade, I wrote President Nixon a letter asking him why we're wasting all this money on going to the moon. And I was a diehard blue dog. We need to be taking care of everybody on the planet, not worrying about going to the moon. I did not appreciate anything outside that. I grew up in a farm, and I got a letter back. Now that was a pretty big surprise when you get a letter from the president. When I did my tour in D.C., I answered a bunch of those letters, And so it really brought back the memory in full, But the letter basically said, it's not what you're seeing as dollars. It didn't try to convince me of a whole lot of things, but it did give me a little new perspective. It opened up my brain just a little bit. And then I had an uncle who came from California, and he was describing his job. He said he was a tool maker. I said, really? I'm thinking wrenches. He said, no, I'm making the tool that's doing the seamless weld for the Apollo capsule. And I thought, wow, that actually sounds kind of cool. And then as a freshman in high school, somebody came to the auditorium and gave us a briefing on the space shuttle. And talking about, here was Apollo, we throw all this stuff away, here's Shuttle, we're going to reuse all this stuff. And I thought, well, that's kind of cool, but I'm still not sold on the idea. It's not, I'm a chicken farmer, I'm going to become an engineer, but I don't know about space. So luckily, I kept going. I worked pretty hard, and let's see, what did I do? I didn't mean to do that. And worked my way through college, survived a mechanical engineering degree, and all the potholes of being out on your own. I grew up in a family of 10, pretty well-controlled environment, and living on your own, a lot of opportunities for mischief. And I was accepted into grad school because the jobs were just not out there, and I got a phone call, and I couldn't even read the name. I couldn't pronounce it, but I made the phone call. I called back, and it was a German rocket scientist, and he had gotten my resume from one of the events, and he just had a couple of questions. The main question he had was around my work experience, and I'd done a lot of construction work and had worked a lot of long hours to make the money, and he said, "Did you really, Chris? Did you really work 80 hours a week?" And I said, "Well, I think I underestimated." He said, "Okay, I have a job." That was it. Show up. Here's your start date. Show up. No, nothing else. And so that was the beginning of a really cool journey. But I think if you're keeping score, I've just described about half a dozen people who helped me get steered in this direction, either knowingly or unknowingly. And so it's really, in my mind, and one of the important things is to recognize that you didn't get anywhere by yourself. We like to think we did. But it's on the backs and shoulders of a lot of people pulling for us. And so, in general, NASA just continues to resonate with a group of us, and there's a group that'll never like it, but there's a whole bunch of people in the middle, and those are the ones that I think we have an opportunity to influence. And it's partly because of the kind of questions that we all have, and NASA's still working around trying to find those questions. So when I came to work, I'm obviously not dressed right. I got told to dress different, and I'm surrounded by brilliant people, and I'm not feeling like I can be there. And then I realized that they're different than when I was at college. And I realized they're different from me, and I realized they're all introverts. And I didn't get what that meant until I went to NASA. You guys haven't met an introvert yet. And I knew I wasn't one. So it was the first of the non-technical parameters that I learned in my new profession. And so, but NASA's full of a bunch of people who kind of dare to dream and then dare to go ahead and do. I told my son, he used it in one of his speeches about the difference between it. All you scientists, don't be offended. But I told him the difference between the engineer and the scientist. He said, "What's that, Dad?" He said, "Well, the scientist looks at a pretty girl across the river and says, 'Wouldn't that be cool to kiss her?' And I said, 'The engineer builds a bridge.'" And so we're about daring to do these mighty things. And I guess it was Roosevelt that said, far better dare to do something mighty and have those glorious triumphs than to live in the neverland of the gray who didn't ever try to do much or never fail much. Better to have the failure. And that's been kind of part of my life. I use this picture just for a quick reminder of the environment that the astronauts live in. Recently, Luca Parmitano, one of the astronauts, was on a spacewalk, and probably didn't hear about it. Some of you may have heard about it, but he nearly drowned in his spacesuit, and barely made it back into the module. There was a leak. These spacesuits are fairly complex. Not a lot of sensors. We all talk about our test data, but not a lot of sensors, not a lot of opportunity to see what's going on. And before he could get back in and get unsuited, he was drinking all the water that was coming into his helmet so that he could continue to breathe. And so it's an unforgiving environment for small mistakes. And we have lived through those. But in general, everybody sees how simple it looks, right? We do that to ourselves. And so a lot of hard work, and the program and the agency goes through a lot of cycles. This business is not for everybody. I've been through 7 canceled programs, and 1 retired program, which is the Space Shuttle. We just landed the last vehicle 2011, June. And it's still got a big draw. And yet what I hear out in public is, man, I hate you guys went out of business. Are we still, why did we quit? And I try to remind people we've still got a space station, we're still operating, and we're basically in a transition phase. After Apollo, that program actually, people don't realize it, that program was only about 10 years long. Shuttle program was 35 years long. And after Apollo, there was about a 9 or 10 year gap before Shuttle came on. So we're in a transition. What did Mark Twain say? Rumors of my demise are much exaggerated. We're still there, and still delivering on amazing missions. So even with all the noise and the blogs and the bureaucrats, can I say that? We are still doing the things of Apollo, of Shuttle, of Chandra, of Voyager. It's what's going on. We're still asking that big question of why are we here, and are we alone? I mean, the are we alone thing is getting more interesting. I keep waiting for hello. But the shuttle program was an amazing success, and yet it doesn't get the kind of press unless there's a problem. 135 missions, 10 times more than we flew in Apollo, at a fraction of the cost. Apollo program was 3 to 4% of that same budget, discretionary budget I was talking about, versus the 0.5%. And so we've got rovers on Mars. Some people get excited about that. I'm a human spaceflight guy. I think that's what we humans are about. Again, back to my point. And so some people will say, well, even with all that, so what, Chris? And sometimes I say that, but we're changing. We're in a phase of transition. We just recently announced crew missions. We started a cargo program for station with I call it new entrants into the field of spaceflight. So we're basically transitioning the low Earth orbit operations to industry so that NASA can focus on the deep exploration activity. And that's just what we're doing. We're focusing on that next phase, and that's the Space Launch System, the SLS rocket, which we've not been this busy since the early 80s when Shuttle was in its early development. And so it's a real rocket. We are 3 years away from first flight. So in terms of the gaps, this is right consistent with the gap we had after the Apollo program. And we've got engines in test, we've got the vehicle in build, and there's a lot of pictures there. Software is over 50% done, which is, long pole, and we're doing that in-house, so it's kind of exciting, kind of scary. And this is just a quick shot of some of the tooling and facilities that are actually just one state over in Michoud, just outside of New Orleans, where we build the core stage. So that's where we used to build the external tank, is now going to be the core stage, 27.5 feet diameter, and quite a bit taller than the shuttle program. And the vehicle is actually kind of opening up, how well that comes up, opening up the trade space. So this is about moving out of low Earth orbit back into exploration. I had some of my Apollo generation guys that would always talk about we're working our way from exploring the moon to being stuck in low Earth orbit, and pretty soon we'll just be doing taxi tests. Well, we've turned that around. I think it's good to give a little perspective. Low Earth orbit, if the Earth is a golf ball, low Earth orbit is your thumbnail. 200 miles up is your thumbnail. And the moon is a yard length away. So that's thumbnail, 4 hours to get there, 300,000 miles, 4 days. And Mars is a half a mile down the way. So, and maybe 9 months to get there. It's a big challenge to start thinking about this broader exploration term. And so this capability we're talking about is all about attacking that challenge. So the Space Launch System is going to be a significant enabler for lots of missions, be it to the moon or to asteroids or to Mars, and that's where we're headed. Just one quick picture of the first flight. Like I said, this fall in December, Exploration Flight Test 1 will be a demonstration of the Orion crew module. The primary effort on that is to get out to lunar reentry velocities and test the heat shield. So today, shuttle flies at 17,000 miles per hour. Coming back from lunar into Earth entry is more like 30,000 miles per hour. So a lot more heat to dissipate, and so this is going to be a big test of the heat shield. And then 3 years later, we're going to be flying the first manned mission. 3, 4, and whether it's manned or unmanned, there's still a lot of discussions going on. Flight test. But one of the more really, really cool things that this capability is going to do is get us into robotic missions in a much faster way. And what I mean by that is today it would take you, the Europa mission. So one of Jupiter's icy moons, most people believe it's got liquid water underneath. That's a really exciting place scientifically for a robotic mission. And it takes about 7 years to get there in today's technology, and with the SLS it'll be about 2. So scientists that are looking to gather some data, because it takes them 10 years to build their instrument, and then 7 years to get there, and then they pretty much have one career on one mission. We're really moving toward just shrinking the mission. But I got to tell you, I wanted to give you a little thumbnail of living through the shuttle development efforts and hook this back to the engine that I'm talking about. And things were a little different in the 80s. I don't know who that guy is, but he used to have dark hair. And can you see the smoking discouraged sign? There were 6 of us in an office. 1 smoked a cigar. 3 were heavy smokers, and it was definitely a different world. There was no personal computer, which is actually a great thing in terms of communication, because you had to actually work together and talk to each other. There's no email, and for sure not a social network, which is antisocial, but and no cell phones. Well, the closest thing to a cell phone was on Star Trek, and I'm not talking Next Generation Star Trek, the old one. That was what we were thinking about. And it was really busy, you know. So being a rocket guy, I got to talk just 1 second about the hardware. Sorry, but 70,000 horsepower out of something the size of your sedan engine. I mean, just sit back and breathe that in. But what you see in the middle there is a turbine blade. It's about a half-inch high, and it has to produce 700 horsepower. So there's so many gee whiz facts I could go on and on. The one I like is that, you know, it's drinking fuel. These engines would drink fuel that would empty your swimming pool in about 25 seconds. And the vehicle itself, where did that picture come from? Uh-oh. Technology. The external tank, the orange thing in the middle, is actually the structural backbone for the whole stack. And to get the right performance that we needed, we had to have a pretty thin wall. It's got, if you took the thickness of the skin to the diameter, it's the same as an aluminum can. And yet it's the structural backbone for the 7.5 million pounds of thrust that are driving through it. And we were full of trying to learn about how to operate this vehicle. Oh, there's what happened. There we go. Anyway, Shuttle's old. It's gone. We retired it. But we were living through failures at a pretty high rate in the 80s. And what you see here is an engine laying in the flame bucket down there with me walking by it. And it wasn't supposed to be in the flame bucket. A lot of people, you know, the old term rocket scientist, you don't have to be a rocket scientist. We weren't scientists, we were doctors. Rocket doctors practice, and we were trying to figure out how to make this machine work. You know, first ever reusable rocket, the high performance, the staged combustion, all those things. And it was a pretty good adrenaline buzz to have a failure and then to realize, you know, we're trying to fly in 2 weeks. And we got this smoking hulk in the flame trench, and are we going to be able to figure that out? And then you bring all those brilliant people that we talked about, and they start analyzing the data like we're supposed to, and pretty soon they get done and they say, you know what, I don't think it happened. After 2 days, that's what you're going to give me? I don't think it happened? Look, you know, it's kind of, so it's really humbling when you're brilliant people and you're surrounded in that, you know, basically that's their conclusion. So this machine was a very humbling activity. If you didn't get humbled, you would be scorched. I mean, that's just all there is to it. And I had one mentor that told me, he said, you know, 1,000 successes teach a few people a little bit, but a failure teaches a lot of people a lot. And so if you think about in all your courses, when did you learn the most? You know, more likely when you had a hard time on a test, you learned a lot. So we moved on after getting these things and continued to what happens in a program that's operational. You start pushing the limits. And that guy that was at my high school said, you know, this is going to be 60 flights a year. It's going to land on any runway. There were all these expectations that were sold, and we're sitting here trying to make good on those expectations. And so there's a lot of pressure to start getting the vehicle to be able to turn around at certain rates and push it hard. And what happens there is you start reducing the slack that is in the system. So where you had 3 or 4 people doing something, all of a sudden you got 1 or 2. And then you got even, you know, so it's pulling the slack down. Think about slack. Think about the airlines. I was stuck in Atlanta 5 hours just recently, yesterday. The slack in the system, if a problem happens, you got no room to deal with it. That's what happens in the airline industry today. If there's a you know, a tornado or a little weather problem 3,000 miles away, it affects the whole system. And that's what happens as you're pushing into this level. And it's a normal process. And as time goes on, just like in Apollo, people got less and less interested. So we've got a bad way about making it look really easy. Well, I was on the flight readiness program at the end of the mission, and everybody, all of the different element directors came in, and they said, they all came back and said the flight was nominal. Nominal. 6 million pieces working together flawlessly, and we call it nominal. So I couldn't stand it. I mean, again, the introverts versus the not. I said, guys, bring me the Greek letter phi and put it with that. It's phenomenal. That's what we did. And so, but over time, just like with Apollo, you know, people just kind of get to thinking it's pretty normal, routine, matter of fact. The press loses interest, the public loses interest. Those two are very intimately connected. And Congress loses interest. Kind of a fickle friend we have there. But even so, they probably never really appreciated the uncertainties that you're dealing with anyway. Until you end up with a tragedy. And that's when, that's when the curtain gets pulled back on everything you don't know. And people really start waking up to, wow, what happened to that shining emblem of failure is not an option? You fall off you get knocked off of the pedestal. And it's tough. I worked all of them except the first one. And, the first thing in these things is really accepting your own culpability in how you get there to be able to then move forward. I think it was Herbert Hoover that said the great liability of the engineer is the tough one. He can't bury his mistakes like the doctor, or he can't argue them away like a lawyer. The engineer's mistakes are out there in full public view, and you got to own them. And unlike another kind of national tragedy, a bridge failure or an airplane accident, we fail in a very public way. A symbol of national pride, and we fail. So that kind of thing really has a dramatic impact on your community of practice and everything else. I'm not trying to over-amplify it, but we really did. What happened there is that shell that people like to call certainty was busted. And nobody likes that. Nobody. We all like to think we got some certainty. And so then here is this thing that people said, it's just old hat. And we break it open. It's like, oh, wow, what else don't we know? Human nature says that's kind of scary. I don't want to deal with that. So the challenge that I put on ourselves is thinking about the cultural aspects of these kinds of tragedies. And I distinguish that from failure. Nobody wants a tragedy, but a failure in our business is part of what we do. So one of the things that came out of the Rogers Commission was the idea of normalization of deviance or complacency and all these things. There's a lot of books written on it. There's probably some pieces of truth in everything written. Being there was no complacency in anybody there's no such thing as complacency in this business. It is, but I do think there is a human element that we don't appreciate. And it starts with the kind of culture you have. And we call it the hero culture. After JFK was martyred in our business, we became no failure's not an option. And that's the hero culture. There's a good, bad, and the ugly side of the hero culture. The hero culture is that there will be, we'll put a team on this and we will fix it. I don't care what it is. That's the good part. The bad part is that if it's really hard, we'll work harder. And then the ugly part is, if you're not with me, disagreement, if you're not with me, you're against me. I mean, how many of you have been on a team where somebody wasn't agreeing, you kind of didn't appreciate that? Well, that's the problem in the hero culture, is being open enough to listen to other options, to listen and consider the other possibilities. And so that's the culture we're living in the shuttle program. And like I said, it's got good, bad, and ugly. The other piece of it is how your brain works. So I used to didn't care, but I do now. The brain is a very inefficient machine. It uses 30% of your energy all day long and all night long. It's crunching away calories. And so over evolution, it said, well, we need to be able to make this thing not use up all our calories. And so the brain starts creating scripts. It simplifies complex problems and starts developing scripts about how to operate. So you can brush your teeth while you're doing something else. Or you can take a shower and not even realize you did. Those scripts just run. You can get to the office and not know how you got there. Because that's just running in the background. And that's part of what happens in trying to operate complex systems, is that you make decisions, and over time, those decisions, they could be really complicated decisions, but you simplify the system so that you can make a complex decision about this little widget. And then when you made a decision, you decide to fly or don't, and it's successful, you baseline that simplification. And then over time, the complexities dissolve. So there's a piece of this that's about how our mental models get crunched down. And that's the real challenge that I think we all have in our objectives, is to stay constantly curious about what that next thing might be. And it takes some risk. Now, this is just two old inventors. Eli McCoy, who invented the real McCoy, which you guys can go research that. I'm not going to go into it. And Thomas Edison. But they were about continuing to work hard and get things that weren't ever thought of. And they had to accept the fact that I find so hard among our engineers, that there's more than one right answer. Every situation has more than one right answer. I don't care what the book says. And it's critical. I didn't learn it till I was 40, so don't worry. But don't learn it the hard way. And then a few years ago, I actually got to meet Ellison Onizuka, the wife of the Japanese Challenger astronaut, and it was really she was at a shuttle launch. I'm there as part of the mission management team, and actually got to go and visit with her, and it was a great event. She said, "Look, you got to just keep going." She said that's what he wanted, and that's what we got to do, and that's what we owe it to all of those explorers, some of whom we've never heard from again. We owe it to keep going, and we do it, a lot because it is around that other human nature factor of why are we here, where are we going, and it really does make me become more and more a believer. I mean, I'm a believer, and I'm not going to go off into a religious conversation, but God intended us to stay humble. That's why He gave us so many questions. And every question we ask, we get two more questions. And He drives us. I want to say one last thing about the Challenger. Richard Feynman was on the Challenger Commission. He was a great physicist. You can look him up. But he wrote an article in 1964 at the Galileo birthday celebration in Italy. And in that article, he talks about the role of science in society. And he describes this thing about uncertainty and control of what us humans really like to manage. He said, but if we were really smart, we'd recognize that without some uncertainty, without some question, without not knowing, you completely kill the future. There is no possibility. And I thought that was really a great logic path of recognizing uncertainty is important, and we need to embrace it for our success. And it's not natural, but you can learn it. I actually have an example of how you can learn it. My son and I decided I always wanted to hang glide as a kid. Never had the guts. When my son was 16, I got him an opportunity to go do a demonstration flight. Not thinking that I would go, but I did. And we decided we wanted to learn how to hang glide. So we started practicing on these little bunny hills. And the first thing they teach you in that is that the control bar, this thing wants to trim out. So you got to learn to run like, what do they say? Run like a coyote, Wile E. Coyote, but don't push on it. You got to have light hands because it wants to trim. It wants to fly. So as you're accelerating down this hill, you're trying not to push on it, and then all of a sudden your feet come off the ground. And the first thing you do is you grab that bar because you're going to fall, And sure enough, all you do is drag that flight, that right down onto the ground, right onto the wheels, and you roll out and you skin your knee. I did that a couple of times. And finally he says, no, you got to just have light hands. 2 lessons from hang gliding. One was light hands, and the other one was don't look where you don't want to go. Great lessons for anybody. Don't try to control, and don't over control, and don't look where you don't want to go in lots of situations. But it's something you can learn. And so what I'm saying is that's muscle memory. That's physical muscle memory and mental muscle memory about embracing uncertainty. And sure enough, we learned how to fly and launch off of something I didn't think was possible. That's a pretty scary platform when you first walk up to it. So in the end, we are going to keep pushing forward, and we're going to keep learning from our past and our opportunities. And I think I mentioned three things in this little talk that I called the engine of possibility. The engine of possibility. And the engine, so being a propulsion guy, I'm going to bring it into a car engine. It's got to have fuel. Starts with fuel. The fuel in the engine is your curiosity. That is that component that is you're wanting to convert into kinetic energy. That curiosity. The thing that converts it into kinetic energy is your courage. So the machinery is all of that, the transom, the pistons, all of that stuff. That's courage. Because you got to have the strength to get through these problems. You got to have the courage to ask the next question. You got to have the courage to consider you don't know that next answer. But all of that's a lot of power moving around, a lot of places, a lot of machinery. You need a lubrication. You got to have something to manage that friction. And that's your humility. Humility is what breaks down those barriers between us as individuals. Humility is what makes us realize that we don't know it all. And that's what creates an environment for success in this exploration adventure. Von Braun, when he went to Washington after the Apollo program, he said, when we flew the first satellite, the Russians beat us. We flew the first satellite, we're catching up. He said, we danced in the streets. He went to Washington and he said, don't put your dancing slippers up. We still got more to do. And he's right. And I think there is more for us as a community. And I really appreciate your time to listen, and hope there was a little something in there for you. And if not, there's 1,000 questions I can try to answer. Anyway, thank you.
Thank you so much. Really appreciate the talk. Very inspiring and energizing. So let's hear from audience if you like to have questions, please.
Thanks
Sir.
for coming. My name is AJ. I'm a junior in the industrial engineering program. Due to the advent of civilian space programs such as SpaceX and Virgin Atlantic trying to get into low orbit, and due to the decline of NASA funding over the recent years, do you feel like NASA has passed the torch of innovation and given the cutting edge of technology in terms of space travel and all the related fields to the civilian sector? Will the next breakthrough be from the civilian sector of aviation, or is NASA still relevant in the next best thing?
Well, that's a really well-spoken question. Personally, I am convinced that we can hand over a whole bunch of what we already developed over these 30 or 40 years in the industry, the emerging industry. The entrants out there are taking full advantage of it and trying to turn it into something affordable. And it's bringing a level of interest into science and space that I'm excited about. So to me, it's a both. This is where the power of the and comes into play. And so that's part of the policy, was to transition our low Earth orbit operations into industry. And hopefully they can make it more affordable and do what industry does best, while NASA starts focusing much more on the deep exploration aspects. So I think it's an and.
Other questions?
Why haven't we gone back to the moon to explore even further, or is it a staffing problem that there's limited staff and so all resources are dedicated mostly to the Mars missions?
So let me be clear. We don't actually have a destination yet. There's a whole lot of policymakers that are having conversations around where is the next mission. The reason we didn't go anywhere before was we were focused on building and assembling the space station. So it's a multi-step process, multi-generational. So the shuttle enabled the station, but the shuttle could not fly outside of low Earth orbit. So, and I don't know if any of you guys recognize, but we don't keep flying one vehicle and try to build another one at the same time. There's not enough money. You actually have to stop to create the restart. So that's where we're at. We're in the capability phase, and then the location, be it the moon. Europeans love the moon. Everybody likes Mars, but they think it's too far. So there's a lot of conversations going on around there. But we're definitely getting beyond LEO. Okay.
Yes, please.
Hi. I wanted to ask about the Mars One program. I know they're getting advised by different agencies, like NASA is advising that program, and they're giving very early dates on when they can complete a mission to Mars. How viable do you see that happening?
So it depends on the mission. With today's technology, I'm trying to think of the guy's name that was trying to do a sprint to Mars in 2022, when it's very, you can do a direct return, but you don't stay. You don't even orbit once. You just go around it and do a direct return. It's a 500-day mission. The technology to do a 500-day mission is within reach, but it's not here. The kinds of so unless we could have had hypersleep, there's a lot of fluids to be managed in that time. So it takes a very large spacecraft, which could today, less the SLS, there's not that kind of throw to get that much mass. The kind of missions that will have the ability to stay at Mars are half the size of the space station. So a lot of resources have got to be pre-positioned because we really don't like to just abandon people. That was one of our objectives. So it's a little more complicated. I our hope is that before 2030, we will have human missions to Mars. So that's still pretty close. That's just 15 years away, 16 years away, which I got to tell you guys, that's not far. You know, I don't know if I answered your question, but you can try again.
Any other question?
You mentioned engineering often has more than one solution to a problem. So what is the state of progress, I guess, on other solutions to space travel besides chemical rockets?
Well, that's one of my favorite subjects. And so there's a lot of work in propellantless progress, solar cells, tethers. Electric propulsion right now is probably the next big step. Unfortunately for humans, it's a great capability for the robotic missions, but not so much for the human mission, because we really got to manage the radiation exposure in deep space. So then for the human mission, you really talk about speed. You're working, how do I reduce 9-month transit time to where I can get into some shelter into 3 or 4 months? And that's when you start thinking about a nuclear system, primarily, which is not that hard in reality. In the 60s, we had several hundred tests of nuclear rocket, the NERVA, and it's still a chemical system, so it's not making that next big leap you're talking about. The warp drive, we got a ways to go, Scotty. But with a nuclear thermal system, we think we can reduce the trip times almost in half, maybe a little more, depending on size, and of course the window, because Mars has got that big elliptical orbit. So, pretty exciting time.
Is the research, though, still hypothetical, in that there's not any actual tests being done on prospective systems?
Oh, no. So I mentioned three different capabilities. Propellantless, we're flying solar cells today. Electric propulsion is flying today. Small thrust, though. We measure it in mouse farts per fortnight. So trying to get a higher power system. Nuclear thermal, we're actually able to do a lot of work through simulated nuclear system. So I'm talking about real tests, but it's using depleted uranium. And so we can actually do the combustor, the physics, and all the rest of it without actually having a hot nuclear, a hot rod, a hot reactor. And it's actually being done. We're developing the fuels and running tests in we call it the N-trees, and I've forgotten what that stands for.
We have one more question. There's one. Yes.
I know NASA's been working with Russia for a long time, so I'll start 2 questions. One, where is the current status of that? Are we still having a good relationship with Russia on that? And 2, do they use NASA with other countries? For example, India. I know India just launched a satellite around Mars.
So the first question is around the Russian relationships, and I think I talked about that before. Today we are fully dependent and partnered with the Russians for the space station. We buy seats to fly the astronauts to the station from the Russians. And the commercial industry is dependent on the Russians for 2 different rocket configurations. One is orbital, flies the AJ-26, which is an old NK-33 refurbished, and the Atlas V flies the RD-180, which both are still manufactured in Russia. So now, as far as other countries, that's way over my pay grade. It's a State Department question, and I have to leave it hanging there.
Senior.
Thank you.